Now viscosity. Viscosity, that is the characteristic of fluid due to which the fluid opposes the motion of itself during the fluid flow. Now, why this happens? Okay. So, whenever the fluid flow is there, the flow that will be the laminar flow means what? Say, in this figure, the laminar flow that is represented. Suppose the fluid flow that is flowing in this particular direction. Now, fluid flow that will be always with respect to the stationary surface. जो सरफेस ऊपर फ्लो થતો હોય તો બી સરફેસ સાથે કોન્ટેક્ટમાં હશે. કોઈ ટ્યુબની અંદર ફ્લો થતો હોય તો ટ્યુબની જે વોલ હોય that is also the stationary surface. Okay. Now, if we think about very first layer of the fluid, which one is in direct contact with this stationary or steady surface, that will be steady due to attractive forces between the molecules of the fluid and molecules of the surface. But now, as we move away from the surface, the attractive forces becomes weaker one. And due to that, the different layers will flow over each other with different velocities. It implies that here the flow of the fluid that will be like this, one layer will slide on another one, and there is the relative velocity between these two, and due to that the friction will be there which opposes the motion. So this characteristic that is known as viscosity, and the force which opposes the motion that is known as viscous force. હવે જો આ ફિગરમાં જેમ જેમ ઉપરના લેયર બાજુ આપણે જતા જઈએ અથવા તો સ્ટેશનરી સરફેસ થી દૂર જતા જઈએ, એમ layers are moving with continuously increasing velocity. Now, suppose in this particular fluid we consider any particular element A, B, C, D. A to B, that is L. Suppose the velocity of the fluid that is V. Now here, suppose we think about this upper layer, then upper layer, which one is moving with velocity V, will cover the distance equal to V into delta T in time delta T. So after time delta T, our element of the fluid, which one was under consideration, A, B, C, D, that will be now A, C dash, D dash, D. Leno shape change thayo here. Okay. So shearing strain generate thayo. But as time increases, the shearing strain also increases. ID તો સ્ટેડી રહેવાનું છે, આ આગળ ને આગળ જશે એટલે shearing strain that will be increasing one. હવે solids માં જેમ shear stress directly proportional to shear strain હતું ને, અહીંયા આગળ strain continuously changing one છે with time. એટલે આપણે ફ્લુઇડના કેસમાં સ્ટ્રેઇનની જગ્યાએ સ્ટ્રેઇન રેટ કન્સિડર કરવો પડે છે. સો સ્ટ્રેસ proportional to strain rate. So if we take the ratio of stress to strain rate, then that is the shear modulus in case of fluid flow, and that is known as coefficient of viscosity. That is known as coefficient of viscosity. Now here strain, that is delta x by L, and if we want to take strain rate, then divide it by time. So we can write strain rate, that is delta x upon L into delta T, that is a strain rate, and the stress, that is as usual force upon area. But now delta x by delta T, that we can represent by velocity. So we can write the coefficient of viscosity, that is the measure of viscosity for the given fluid, that is force into L upon AV. And the SI unit of this one, that is Poiseuille, on behalf of the name of scientist Poiseuille, and it is represented as PI. But Poiseuille means what? So here if we substitute the unit of force Newton, for length meter, for area meter square, and for velocity meter per second, then finally we will get Newton second per meter square. And this Newton second per meter square itself is called Poiseuille. Now if you want to find the dimensional formula, now again simplify this one. Poiseuille, that is Newton second per meter square, but Newton, that is kilogram meter per second square, into second per meter square as it is. So finally we will get kilogram meter per second. So for kilogram M1, for meter L1, for second T1. So M1 upon L1 T1. So resultantly you will get the dimensional formula for coefficient of viscosity, that is M1 L minus 1 T minus 1. And its a CGS unit, that is poise. And we can write poise, that is equal to dyne second per centimeter square, or we can write gram per centimeter second. Clear to all of you? The liquid for which the coefficient of viscosity, that is small one, that liquid can flow easily, and the liquid for which the coefficient of viscosity, that is large one, that can't flow easily. Say, suppose we think about water, and with respect to that we think about honey or castor oil, like that. Then water can flow easily compared to castor oil and honey. So for water, the coefficient of viscosity, that is less compared to those two. So this thing happens. Clear to all of you?